So the first method, we just look at two methods. One is the Jacobi, well, three methods, sorry. Jacobi iterative method. And I'll give you the intuition with a simple 2x2 problem. Okay, so those are A's and B's are constants. So this is how the Jacobi method works. You'll write this as, rewrite these equations the following way. You'll try to solve for x1 in terms of x2 from the first equation. So that will be b1 minus a1 to x2 divided by a11. And then you solve for x2 in the second equation. So that will be b2 minus a21 x1 divided by a22. Okay, so this is how the iterations work. Make a guess to the solution. X1 0, X2 0. Okay, what is this? That's just some guess. You could just start with 0 0. So for iteration 1, what you do is you compute the new value for x1 by using this formula. You see what I did? I basically subbed in the value for x2 in this equation and x1 from this equation and got a new estimate for x1 and x2. Next, I go for the second iteration, iteration 2. X1, second iteration is b1 minus a12. Now use your best guess for x2. That is this one, right? So x21, a11, x22 was b2 minus a21, x11, a22. So that's from iteration 1. And this gives you values for iteration 2. And you just keep doing that till some termination. So the way the termination criteria we'll use, and there could be many ways you can do this. The one which is one way of doing this is to do this till the norm of x1 I minus 1 is less than epsilon, and x2I minus 2. This is what it's saying, is that you look at the difference between the value of x1 between two successive iterations, and if it's less than a tolerance, some value, some small value, for example, -3, then you just terminate. And you also want to do that for x2. So both of them have to basically not change much.
Professor, could we combine both of these distances and
Right.
turn them into a magnitude of the adjustment factor?
Yes. 1 second, once he wants to go back. That was what I was coming to. You can also combine them by taking a norm of the whole thing. So that's cumbersome, because with that, you need to check like 10 of, if there are 10 variables, you need to check 10 variables. But here's another way. You could just combine them in the following way. X1I that's one way of combining, but you could come up with various other ways to combine. So this epsilon is a user-defined tolerance. Okay, now that we've got this, let's put it to practice. We'll just do the same problem we've done in this chapter, because we know the answer to it's 1, 2, and 3. And let's see what we get using this method and go from there. So the good thing about numerical methods as a course is that it's very easy to make your own questions, right? You can just put numbers, random numbers in a calculator, get your own problem, and then use the method, and you know what the answer is because you created the problem. Unlike some other courses where you need to know some specific theory about that particular course. Okay, so I'm going to try to solve the same problem which we've done. Solve for x1, x2, x3 using equations are 2x1 Okay, it's a caveat here. Solve for show 3 iterations. Okay, I'm going to say 3 iterations because it's going to take a long time to solve this. I use a numerical method, I used an octave code to solve this. It took me 583 iterations to solve this. Yeah. It's not very fast, but then we'll come to faster methods. I just asked you 3 iterations or 2 iterations. Yeah. I just want to see how you understand how to apply it, not really anything else. Can I also give you the guess? Use an initial yes, x1 0 equals x2 0 equals x3 0 of 0. Here's solution. Okay, let's write it in the form where we can easily do the substitution. So that form is x1 equals 7 minus x2 minus x3 divided by 3. x2 equals 2 plus x1 plus x2. Sorry, 2 plus x1 plus x3 divided by what am I doing? This is 2. 7, okay, it's 2 divided by 3, then x3 equals okay, iteration 1. Okay, let's solve it sequentially. X1 equals 7 minus, our guess is 0, 0, 0. So I'll just put that 0, 0 divided by 2. X2 equals 2 plus 0 plus 0 divided by 3. X3 is minus 3 plus 0 plus 0. This is 3.5, 0.6667, and then minus 3. Yeah, so what was that? The solution to x1, let's go to iteration 2. The solution from iteration 1 was x1 equals 3.5, x2 equals 0.6667, and x3 equals minus 3. Okay, so with this, in this corner, it's easier to check that. Let's sub in the values. X1 equals 7 minus x2. X2 is this, 0.6667 minus x3 is this, divided by 2. X2 equals 2 plus x1, 3.5, plus x3, minus 3, divided by 3. X3 is minus 3 plus 2 times x1 plus 2 times x2. Yeah, I'll leave some space for you to do this, but I'll give you the solution. What I get from this is, so write the equation for x1, x2, x3, just I wrote there, and then show that this will be equal to 0.4166, 4.00, 8.000. And then what I would expect you to do for the exam is, or the homework is, put a table so it's very easy for us to check your answers. So 1, 2, 3, x1, x2, x3, 3.5, 7. Yeah, I just did this using a code. By the way, I'll provide you with the code. So you can see that the first 3 iterations look right, 0.416, and actually also calculates the norm. But it took me like 583 iterations to get the final answer, and I don't want it to do that much calculations. It's clearly something for the computer.